Good morning, class. Let's begin with the unit C of your chapter. And the unit C says energy sources. So here we will be learning about energy sources or the sources of energy. All right. So let's begin. You can follow your book, okay, and underline as I say the sentences which are important. Okay. Now, first topic that we have is sources of energy. We know, okay, we require energy in every activity of our life, right? Everything that you need to do or you're supposed to do, right from walking, eating, sleeping, reading, watching movies, whatever you do, whatever the activities that we do, we require what? Some energy, isn't it? In the night, we switch on the bulb, isn't it? So the bulb glows because of the electricity. So electricity is a form of energy, isn't it? We can listen to the music, we can watch television, we can run our machines at home. All works on electricity, isn't it? We are able to hear the sound because of sound energy. So we see we require whatever the activities that we do in our life, we require some form of energy. For example, here are some examples given on your book. Energy is required to cook food, to light homes, to run gadgets, to move vehicles, to run TV, cinema, radio, etc. We need energy for production in factories and also for crops in the fields. So to meet most of these requirements, the energy needed is in the form of heat and electricity. So most of the time, whatever the energy that we are using are in these two form. That is heat, okay, the other one is and electricity. These, okay, are the two most important form of energy, okay, important forms of energy which we require. For example, we need heat energy for cooking food, and this heat energy is obtained by burning the fuel such as coal, wood, kerosene, or cooking gas, isn't it? At our home we have LPG cylinders, yes, liquefied petroleum, LPG cylinders, liquefied petroleum gas, isn't it? So it is a fossil fuel, okay, the fuel that we get from fossils. We need electricity to run electric motors, fans, etc., and it is obtained from coal and hydro energy or nuclear energy. So we are requiring energy most of the time in the form of heat and electricity. Now let us see what should be the characteristics of source of energy. So whatever the source of energy that you are considering, maybe it as a fossil fuel, okay, or hydropower, okay, or nuclear power, what must be the characteristics? So please underline this paragraph. A source of energy should be such that it can provide an adequate amount of useful energy at a steady rate over a long period of time. It should be safe and convenient to use, economical and easy to store and transport. Okay, so see, first of all, it should be adequate. Adequate means in a large amount, ekdamai zyada. Okay, the source of energy should be adequate. Okay, are you getting my point? And adequate amount of useful energy, and it should supply at a steady rate, understand, over a long period of time, and it should be safe. Whenever you are using it, it should be safe and easy to use, that is convenient to use, easy to use. It should be economical, okay, it should be economical, okay, beshi mango hunu bhaina, not so costly, okay, and it should be easily stored and it can be transported from one place to another. So these are the characteristics of what? Energy source. Number one is it should have adequate amount of useful energy, okay. Number two, it should supply a steady rate over a long period of time. Number three, it should be safe and convenient to use. Number four, it should be economical. And number five, it should be easy to store and transport. So there are altogether 5 characteristics that should, okay, be possessed by a source of energy. Now let's us classify, let us group, or you can say how we can group the sources of energy. So sources of energy can be grouped into two groups, okay, on the point of view of availability. Okay, availability here, we can classify sources of energy in two groups. That is, number one is renewable which is also called as non-conventional sources of energy, and it is the second one is non-renewable or conventional sources of energy. So on the basis of sources of energy, on the view in the basis of availability, sources of energy or energy sources can be of two types. One is renewable, renewable, other one is non-renewable. So by the word itself you can say that when we say renewable, it can be renewed again and again, means it can be used again and again, and non-renewable means it cannot be renewed again and again. All right, so let's begin with the first one, that is a renewable form of energy. Renewable is also called as the non-conventional sources of energy. So please remember, renewable sources of energy is also called as non-conventional sources of energy, non-conventional. So a natural source providing us energy continuously is called a renewable or non-conventional source of energy. So the energy that we can get from the nature is basically called renewable sources of energy or non-conventional sources of energy. Sun is the main source of energy for us on earth, which we all know. The energy harnessed from the natural sources like wind, flowing water, tides, ocean waves, and biogas is directly or indirectly derived from the energy of the sun. So that is why we consider sun to be as the ultimate source of energy. So we can use these sources as long as the earth continues to receive heat and light from the sun. Apart from these sources, geothermal energy and nuclear energy are the other sources of energy, which can provide us energy over a long period of time. Understand? So see, now let us try to find out what are the sources of energy which are renewable, means which can be used again and again. Number one is wind, the other one is flowing water, then comes tides, then comes ocean waves, then comes biogas. Apart from this, we have geothermal energy, then we have nuclear energy. These are the sources or the examples of renewable sources of energy. We will be learning them one by one. Now these sources of energy can be used again and again and will never be exhausted. So these are the things that you have in your book itself. So please follow it and underline and mark. Although the wood obtained from trees is also considered as a renewable sources of energy, but trees usually takes more than 15 years to grow fully. Therefore, new renewable of wood as a source of energy takes a long time. So you know that the wood that we burn to cook our food or to produce heat energy is also considered as a renewable source of energy. But to have a fully grown tree, we require 15 years. So it's a very, very long time, isn't it? So that's why it's like a little bit confusing to place wood as the renewable source of energy. So further, cutting of trees on a large scale causes depletion of forest. That is, deforestation will cause, which will result in the global warming and environmental imbalance, right? So hence, use of wood as a source of energy must be avoided. So please mark this point. Use of wood as a source of energy must be avoided because it causes, cutting of trees causes deforestation. It disbalances the ecosystem environment. That is why the deforestation is another cause of global warming, and hence it should be avoided. Using of wood. So thus the main sources of renewable sources of energy are: number one is sun, number two is wind, number two is flowing water, which is also called as hydro. Water is also called as hydro. Number four is biomass and biofuels from the west. Number 5 is tides. Number 6 is oceans. Number 7 is geothermal spots. And number 8 is nuclear fuel. So you see that there are 8 different types of renewable sources of energy. Number 1 is your sun, number 2 is wind, number 3 is flowing, okay, water, okay, number 4 is biomass, number 5 is tides, number 6 is ocean, okay, number 6 is geothermal, okay, and number 8 is nuclear fuels. All right, okay, now let's go to the next topic. Next topic is the first one, sun as the source of energy. Sun is the main source of various types of energy. The energy obtained from the sun is called solar energy. So the energy that we get from sun is called solar energy. What energy? Solar energy. In the interior of the sun, the nuclear fusion reaction generates huge amount of energy. So inside the in the interior, at the inside of the sun, there is a reaction called nuclear fusion reaction, okay, which produces huge amount of energy which is radiated out continuously in all direction in the space. Since the sun is very far from the earth, we receive only a very small fraction of the total solar energy. The solar energy that reaches earth is neither uniform nor equal at all places. It changes daily even at one place. So it is for it also varies during a day. So the average solar, please underline from here, energy reaching the upper atmosphere of the earth per second on the area of 1 meter square is called solar constant. So what do we call it? Solar constant. So solar constant is the amount of solar energy reaching, okay, at a upper atmosphere of the earth per second, 1 second ma, okay, an area of 1 meter square. 1 meter square ko area ma 1 second ma paako solar energy is called solar constant, okay, and the estimated value is nearly 1.34 kilowatt per meter square. So this is the amount of solar energy that is received at 1 meter square of area on the upper atmosphere. Okay, the solar energy reaching the earth is absorbed by land, plants and water bodies like rivers, lakes and ocean. The solar energy absorbed by the land and water bodies causes winds, storm, rains, snowfalls and sea waves, etc., while the solar energy absorbed by the plant is utilized by them in preparing in their food by the process of photosynthesis. So you must remember that sun, because of sun we have winds, because of sun we have rainfall, because of sun the water from the oceans and the water bodies evaporated, okay, and rises up in the sky, cools down there and forms clouds, and these clouds gives us rain. So if there is no sun, there will be no evaporation. If there is no evaporation, no cloud formation, and if there is no cloud formation, there will be no rain. So there will be dry everywhere, isn't it? So this is how the sun is helping us to have a cycle, water cycle. Understand? And at the same time, the food that we eat, we usually get from the plants, and plants prepare their food because of this sunlight. So if there is no sunlight, plants cannot prepare their food, and in turn we will not get any food. So that is how sun is helping us to have or sustain life in the earth. Okay, second one is wind as a source of energy. The large mass of moving air is called wind. Okay, so when large mass of air is moving, okay, mass of air is moving, that is what we call wind. Wind. Due to motion, it has kinetic energy. Now you know, whenever there is somebody or something which is in motion, it always possesses what? Kinetic energy. So the wind, the moving wind, okay, has kinetic energy. So the kinetic energy of the wind is called wind energy. So please underline this. Okay, now in the next page on your book, you will see this paragraph. Indirectly, the wind energy comes from the solar energy. The sun rays falling on the earth hit different areas of earth unequally. Due to number 1, unequal heating of different areas of the earth, and number 2, rotation of the earth, and number 3, local convection currents. We have different wind cycles. So from the very early days, we have been using energy purchased by the wind for various purposes, such as removing husks from the grain, okay, in propelling sailboats in rivers and seas, and in moving vehicles from transportation, and in windmills to draw water from the ground and to grind grain. So wind energy, okay, wind energy is used, number 1, how to remove the husk from the grain, okay, number 2, to sail the boat, okay, to sail the boats, okay, number 3 is moving the vehicles, okay, moving the vehicles, number 4 is to draw the water with the help of windmills, okay, windmills, and also to grind the, okay, grind the what, grains. All right, so number 1, removing the husk. We have seen, isn't it, the grains is a mixture of husk, isn't it? So that husk from the खोस्टा, हक्स भनेको त खोस्टा, चामलको गहुँको खोस्टा चाहिँ केले हटाउँछ, हावाले गर्दा you can move with the help of wind, okay. So that is how wind energy is used to remove the husk from the grains. Number 2 is the sail, to sail the boat. So if you have a boat, and on the boat you have seen a big cloth attached to it, when the wind rushes here, it pushes the boat forward. So that is how the sailboat, okay, the sailing boat is possible with the help of wind energy. Similarly, the vehicles are also made, okay, with the help of this kind of things only, okay. And number 4 is windmill. You have seen a windmill on the TVs, you have seen this kind of windmills, okay. It is attached to a grinder here, understand, and this is used to grind the grain, okay. गहुँलाई पिसेर आटा बनाउनमा is used, okay. Wind energy is used here in windmills, okay. Along with the grinding of grains, windmills are also used to draw water from the wells, okay, draw water from the wells. So these are the uses of wind energy, okay. Then number 3 is flowing water as a source of energy. The kinetic energy possessed by the flowing water is called the hydro energy. Please underline this and put a star mark, hydro energy. Now hydro energy too comes indirectly from the sun. The solar energy is responsible for water cycle in the nature. So as I said to you earlier, isn't it? Water in ocean, rivers, lakes, etc. absorb solar energy, and then what happens? It evaporates to form clouds. See? So the clouds move due to the air currents, and ultimately water comes back on the earth in the form of rain and snow. See, this is how the thing is taking place. Suppose say this is your mountain, okay, and this is your sea. What is this? Sea, okay. Let me use the blue one. So this is your sea. So here you have sea, here you have land. So in the daytime, when there is a sun, what happens? Water evaporates up from the ocean and the seas or the lakes, and it forms clouds. These clouds rises up or moves, okay, and becomes cold, okay, and starts to precipitate, that is rainfall. So this rain falls here, okay, and fills the river, okay, and the river takes the water back to the ocean or the seas. So here you see that there is a cycle created here. This phenomenon is called as water cycle. So who is responsible for water cycle? Sun. Okay, so man has been utilizing for centuries the energy of the flowing water in rivers for rotating the wheels of the water mill used to drive the floor mill in the remote hilly areas, and for transporting heavy logs down from the forest in the hilly areas to the downstreams areas in the plains. So you see that in the olden days, the flowing water, the energy possessed in the flowing water, that is kinetic energy, is used to run the or grind the what? Grains. Okay, kinetic energy of the flowing water. Similarly, this flowing water can carry logs of wood. So in a way, it is helping to transport the wooden logs from the upper hilly areas to the lower plain areas. So that is how number 3, that is flowing water, can be used. Okay, number 5, that is biomass as a source of energy. Now what is biomass? Let's learn. The waste and the dead parts of the living beings like plants, trees, animals is called biomass. They contain carbon compounds. The chemical, please underline all this, energy stored in the biomass is called bioenergy. So please underline this. So the chemical energy which is stored in this biomass is called bioenergy. Thus, bioenergy also comes from the solar energy. So biomass such as wood, cattle dung, crop residue, and agricultural waste like bagases have been traditionally used as a fuel to produce heat energy for domestic as well as commercial purpose. So bagases भनेको चाहिँ के हो? उखुको रस निकालेर उब्रेको खोस्टा हुन्छ नि, so that is called bagases. Okay. Now biomass is also used to produce biogas by the decomposition in the absence of oxygen. The main constituent of biogas is methane. Please underline this, mark this here. Methane. Okay, methane 65%, and the rest is a mixture of carbon dioxide, hydrogen, and hydrogen sulfide. Okay, so biogas ma चाहिँ के हुँदो रहेछ? Methane, that is CH4. Okay, then comes your hydrogen, then carbon dioxide. Okay, then hydrogen sulfide. So यो चारटा ग्यास चाहिँ केमा रहेछ? बायोग्यासमा. Okay, so what are they? Methane, CH4, and hydrogen, H2, CO2, that is carbon dioxide, and H2S, that is hydrogen sulfide. Okay, so biogas is used as a fuel to run engines and for generating electricity. In India, we use two types of bio plants. Number one is floating gas okay, holder type, okay, and the other one is fixed dome type. They are also called gobar gas plants because the main biomass used in this plant is the slurry, which is a mixture of animal dung, that is gobar, and water. So slurry भनेको चाहिँ के रहेछ? Mixture of dung, usually cow dung, gobar, okay, plus water. So these two mixtures are fed in the tank. Okay, your tank ma चाहिँ यो के हुन्छ? They starts to decompose, कोइन्छ, and start to produce a gas called as biogas, which is a mixture of methane, hydrogen sulfide, carbon dioxide, and hydrogen. Okay, so that is your biogas or biomass as a source of energy. Number 5 is tides as the source of energy. The rise of ocean water near the coast is called the high tide, and fall of ocean water is called the low tide. So you have heard about this, isn't it? Because of the gravitational pull of earth and moon. Okay, because of the gravitational pull of earth, basically it's between earth and moon. Okay, what happens? The sea level rises up sometimes and falls down sometimes. So when it rises up, it is called high tide. When it flows or goes down, it's called low tide. So this is what we call tides. So this occurs twice a day in ocean. The energy possessed by the rising and falling water in the tides is known as tidal energy. So the tidal energy is harnessed for producing electricity by constructing a dam across a narrow opening to the sea, but this is not a major source of energy because of the following two reasons. So see, you cannot produce a large amount of energy from high tides and low tides, or the tidal energy cannot be harnessed properly because of these following two reasons. Number one is the rise and fall of seawater during tide is not enough to generate electricity on a large scale. Large scale electricity cannot be generated. Number two, there is a very few sites where it is suitable to build the tidal dam. So it is not possible to have tidal dams everywhere. So very or limited places are there where you can have tidal dams. Okay, so that is your number 5, tides as a source of energy. Number 6 is ocean as a source of energy. Water in ocean possesses energy in two forms. Number 1, ocean thermal energy, and number 2 is oceanic waves energy. Do you know the core of the earth is very, very hot, where you have the lava, molten lava, which is also called as magma, isn't it? Yes, so that can heat up the water. So there can be a possibility of the temperature difference in the ocean water, which is called as ocean thermal energy. Okay, and you know the waves समुद्रको छाल सुनेको छ हैन सो that is the other way to get energy. So ocean water you can get energy in two ways. Number one is ocean thermal energy. Now what is ocean thermal energy? Water at the surface of the ocean gets heated by absorbing the heat from the sun, while water at the deeper level remains cold. Thus there is a difference in the temperature of the earth of water at the surface and the deeper levels of the ocean. This difference in temperature is bound to be up to 20 degrees Celsius. So the energy available due to the difference in the temperature of the water at the surface and at the deeper level of the ocean is called ocean thermal energy, that is OTE. Obviously this energy also comes indirectly from the sun. So ocean thermal energy is harnessed for producing electricity by a device called Ocean Thermal Energy Conservation Power Plant, that is OCTEC power plant. So in this way you can generate or harness energy from the ocean. Okay, number B is oceanic waves energy, that is sea waves. Due to the wind blowing on the surface of the ocean, waves move at a high speed on its surface, which are called oceanic waves or sea waves. Due to their high speed, they carry tremendous amount of kinetic energy. All right, tremendous amount of kinetic energy. Alright, so thus underline from here, the kinetic energy possessed by a fast moving ocean waves is called the oceanic or sea wave energy. This energy also comes indirectly from the sun. Okay, so underline from here to here. Sea waves energy can also be harnessed to produce electricity, but so far it has not become possible to produce electricity from sea waves energy on a large scale. However, models have been made to generate electricity from the oceanic waves. Okay, so scientists are working on it to develop a system to generate electricity, or you can say to harness energy from the sea waves on a large scale. Number 7 is geothermal spots or as a source of energy. Now at some places, rocks below the surface of earth are very hot. Such places are known as hot spot. What do you call it? Hot spot. It's not the Wi-Fi. Don't make confusion here. Okay. The heat energy possessed by the rock inside the earth is called the geothermal energy. Now how it is used? Geothermal energy is harnessed to produce electricity. The rock present at hot spot, heat the underground water and turn it into what? Steam. Now when this gets compressed at high pressure between the rocks by drilling holes in the earth by the rocks, to the hot spot, steam is extracted through pipes which is utilized to rotate the turbine connected to the armature of the electric generator to produce electricity. So what happens is that this steam which is at high pressure is taken through a pipe, and suppose say this is the turbine of a generator, this is a turbine of a generator. So this steam, when it is allowed to fall on the turbine starts to rotate. So when turbine rotates, this in turn, this generator produces electricity. So this is how you can harness geothermal energy. In India, there are very few places where geothermal energy is harnessed to produce electricity. One such place is Madhya Pradesh. However, in USA and New Zealand, there are a number of geothermal energy based power plants. Okay, India, where is it? It is at Madhya Pradesh. Okay, now number 8, that is the last one, or the last kind of or the number 8th type of renewable source of energy. So nuclear fuels as source of energy. When uranium nuclei is bombarded, about this we will do in detail in class 10. Okay, don't worry. Right here you just understand that when a big or a heavy nucleus is bombarded, means is heated by a slow neutron. न्यूट्रनले यसलाई हिर्कायो भने चाहिँ यो न्यूक्लियस त के हुन्छ, दुईटा भागमा स्प्लिट हुन्छ, मीन्स फुट्छ. So when it splits up, what happens? It produces a high amount of energy. This energy is called nuclear energy and the process is called nuclear fission reaction. के हुँदैछ? फिजन हुँदैछ. छुट्टिँदैछ. Okay, so similarly when two light nuclei combine to form a heavy nucleus, okay, at a high temperature and high pressure, the amount of energy produced is very, very large. This phenomenon is called as nuclear fusion reaction. So see, you have two small particles that is obviously nucleons. Okay, when they are combined together, they combine to form a heavy nucleus. Understand? So in doing so, they produce a high amount of energy, large amount of energy. The energy so obtained by this process is called nuclear fusion. Okay, so in both this process, the origin of energy is the loss of mass, that is the sum of mass of the products of the reaction is less than the sum of the masses of the reactant. So here what is actually happening is that the mass of the nucleus here is actually converting into what? Energy. Understand? Clear? So this was this concept or this theory was explained by Einstein by his famous equation called as E is equals to mc square. E equals to mc square. This is called Einstein mass energy equivalence. That is E equals to mc square, means mass is converting into energy during nuclear reaction. Understand? So just remember this much. Okay, clear? So what is the energy released? What is the amount of energy released during fusion reaction is 200 mega electron volt. Is that okay? Yes. So this is released by one uranium nucleus. एउटा uranium nucleus ले चाहिँ यति amount of energy is released. Okay, and 2 or 3 neutrons are also emitted. If number of nuclei present are more, each neutron emitted in fusion reaction of the uranium nucleus causes fission in the new uranium nucleus, and thus a chain of nuclear fission reaction occurs, which once started continues till the entire uranium is exhausted. Means, see, suppose you have a big chunk of uranium and it has number of nucleus in it. थुप्रै nucleus छ यो चङ्कमा. ओके, सो इफ यु जस्ट ब्रेक वान युरेनियम न्युक्लियस, एउटा युरेनियम न्युक्लियसलाई ब्रेक गऱ्यो भने चाहिँ के गर्छ, यसबाट निस्केको टुक्राले चाहिँ फेरि अर्कोलाई पनि के गरिदिन्छ, ब्रेक गरिदिन्छ. यसबाट निस्केको टुक्राले अर्कोलाई. ओके, सो इन टर्न इट फर्म्स अ चेन. सो वान bombardment will start a chain of reaction. So this nucleus will break, okay, and the neutron produced by this nucleus will now break the another nucleus. This nucleus will now in turn break another nucleus, and this will continue till each and every particle of the uranium is exhausted. भनेको चाहिँ सक्छ. जबसम्म the nucleus of the uranium does not finish or exhaust, the reaction will continue. So that is why, as a result, such an uncontrollable chain reaction, more and more energy is produced, which may cause an explosion. So an atom bomb is based on this principle, that is uncontrollable chain reaction. But to utilize the energy produced in the process of fission or for a constructive use, such as to produce electricity, the chain reaction is to be controlled by observing some nutrients with the help of cadmium rod. This is done as a in a nuclear reactor. So this uncontrollable chain reaction is controlled by using what rods? Rods made up of cadmium, which absorbs the neutron produced. So जति पनि neutrons produced भएको हुन्छ नि, this cadmium rod will absorb it and thus in turn control the chain reaction. All right, so this is how energy can be harnessed from the nuclear reaction. And from which one? Fission. Okay, not from the fusion. All right, so we saw today the renewable 8 different types of renewable source of energy. Renewable sources of energy is also called as non-conventional sources of energy. So for you all, let me recall again. Number first that we did was sun. Okay, that is the solar energy. Number 2 is wind, that is wind energy. Number 3 is flowing water, which contains kinetic energy. Number 4 is biomass. Biomass is the energy present in the form of chemicals in the animal and plant waste. Okay, then you have tides, Okay, high tides and low tides, which occurs twice a day in the ocean, can be utilized to harness what energy. Then comes ocean water. You can get you can harness energy from the ocean in two ways. Number one is geothermal oceanic energy, and the other one is oceanic waves energy. Okay, and the number seventh is your geothermal spots, which are also called as hot spots, and the last one is nuclear what energy. So these are the 8 different types of renewable sources of energy. All right, so that's all for today. In the next class we will discuss non-renewable sources of energy, which are also called as conventional sources of energy. Okay, so that's all for today. Thank you.